Skill saving it as well.
Really? Yeah.
Alright, we're going to be graphing linear equations by making a table. And the first bit I said we're going to want to use this method when our equation is set up like this. When we have some letter by itself. Whether it's the y variable, or c for cost, h for height, or hours. Okay. So if it's in this form, we can make a table and we can plot the points. So our first example is right here. So the first thing we're going to want to do is make a table for x and y. And when I get these values here, these values are going to be the coordinates for the graph. Now, as you notice, there's nothing in either column. And the place you start on with making a table is you pick the values of x. You pick the values of x. Or you pick the values of whatever letter is not by itself. So in this case, you'd pick values of d, you'd pick values for t, and in this case, x. Now, it's a pretty simple equation, and one of the values of x I'm always going to want to use is 0. So we put 0 in there. And I'll pick a couple other ones. I'll pick 1, and 2, and 3. You want to pick at least 3 points. You want to pick at least 3 points to make sure those 3 points are linear, are in a line. And what we do with each one is substitute it into the equation to find the value of y. When I substitute 0 in, I get 3 for y. And then I'll substitute 1 into the formula to find out what the value of y is when x equals 1. And we continue with 2 or 3. So we've completed our table, and if we notice, if we use consecutive numbers for x, then we should have a pattern going down with y. It looks like my y values are decreasing by 2, which will always be the same as that coefficient right there. Negative 2 means it's going down by 2. So what I do is each of these ordered pair is going to be a coordinate on the graph. So I have 1, 2, 3, 4 ordered pair that I'm going to plot on the graph. Great. I plot all 4 of these points, and they better be in a straight line. Let's just check. So I'll go in order. 0, 3. Tick. So my 4 points are linear. And I have my axes labeled. X is the horizontal one, y is the vertical. And from here, since this example has no context, I'm not talking about hours or days or anything like that, I draw a continuous line through the points. Okay, so there's our straight line, and I wrote the equation next to it, put arrows on it because it goes in both directions infinitely. And just a couple of things to know here about these two values here. This coefficient of the x, this negative 2, that does represent the gradient of the line. So later on in another video, we're going to talk about the gradient of the line. And the gradient of the line is negative 2, which means that if I pick 2 points on the line, I'm going to be going down 2 and over 1, down 2 over 1, down 2 over 1. And this constant term right here of 3 represents the y-intercept. So anytime I have a constant term like that, it shows me where it crosses the y-axis. Alright, let's do another one. Alright, let's try an equation that has a fraction in there. It's not a perfect world, so we won't always get equations that have just integers in them. And we make the table just like this, and we pick values for x. We're in control of the values for x. You don't always have to pick 0, 1, 2, 3. You can pick anything you want. Okay, so the values I pick for x this time, I'm going to pick different ones other than 0, 1, 2, 3. 0 is always a good one, so I'll start there. But since I'm going to get fractions here, if I were to pick 1 and 2, I'd get fraction values over here, or decimal values, which are fine. But if I want to avoid that, if I want to get integer numbers for this y values, then just pick multiples of whatever that denominator is. If it's 1/4, then pick multiples of 4. If it's 3/7, then pick multiples of 7. That way, you won't get any decimal or fraction answers over here. So I'll pick a couple multiples of 3. And we go through the same process that we did here. Substituting each x value into the equation to find the y value. Okay, so I have my table completed. I can do my ordered pairs, but just look at here. Remember how I said how it's going down here by 2. Each time it's going down by 2, minus 2, minus 2. And that was the same as this coefficient right here. That only works when the x values are consecutive. So since these x values aren't consecutive, the number that it's going up by here, it's not the same as here. So we kind of need to pay attention to that. But here, it's all good for plotting the points. So we'll plot these 4 points and look at it in relation to our other equation. Okay, so these 4 points are these 4 coordinates right here. Here's the point of intersection, I can tell. Now we draw our line. Like I said earlier, how these numbers tell parts of the line, the gradient and the y-intercept. The gradient of this line is 1/3. That means I'm going up 1 and over 3, up 1 over 3, and the y-intercept is -4, right there. So those are the bits that tell us features of the line. Okay, so that's it for now, and I'll give one sample problem for you to try.